Okay, welcome to Chapter 8. Before we get started on Chapter 8, I'm going to go over our goals for the next two chapters. Even though in 2021 we won't be covering Chapter 9, I just want to talk about what the goals are for that as well. So the goal for Chapter 8 is to be able to write the equation of lines and the equation of planes in 3 space. So you already know how to write equations of lines in 2 space. That's what we worked on in grade 9. But now we're going to talk about 3 space. So there's different forms of the equation of a line. Remember in grade 9 when you did the equations of a line in 2 space, we had y equals mx plus b and we had standard form. So it makes sense, there's 2 forms. These forms look a little bit more different from each other. So for the equation of a line, I can have a vector form, parametric form, Cartesian form, and symmetric form. So we're going to take a look at each of those in the first couple of lessons. And then we're also going to look at the different forms of the equation of a whole plane in 3 space. And there's different formats for that. We can look at the vector form, the parametric form, and the Cartesian form. And you'll find that they're similar to the equations of the line. So we end up going through that quite a bit quicker. For Chapter 9, the goal is to actually be able to talk about the intersection of these things. So how do 2 lines intersect in 3 space? And you'll remember that we did the intersection of 2 lines in grade 10 when we talked about solving a system of equations using substitution or elimination. So now we're trying to find the intersection point in 3 space. We can also talk about how does a line intersect a plane, or how do 2 planes intersect each other, or how do 3 planes intersect each other. There's multiple different ways that can happen. And then also in Chapter 9, we would normally take a look at finding the distance from a point in 3 space to a line, or from a point in 3 space to a plane. I'm going to try to briefly touch on some of this stuff. I have a summary sheet that I'll go through with you guys just to talk about the different possibilities. So we've spent the last 2 chapters looking at vectors. And in a lot of ways, they seem similar to lines, but lines are not the same as vectors. So we want to talk about what are the differences between them. We're going to use vectors to describe lines in this chapter. So similarities and differences. Lines are bidirectional, so they go in 2 different directions. The vectors are unidirectional, so only one direction, and we could think about the opposite vector would be the bidirection on the line. A line defines a direction, but there's nothing to distinguish forward from backward, whereas a vector has a clear forward and a clear backward. A line is infinite in both directions, whereas we looked at line segments sometimes in grade 10, and a line segment has a finite length. A vector, we call it a finite magnitude, so similar to length. Lines and line segments have a definite location. They can't be moved around, whereas a vector has no fixed location. We often take that vector and move it back to the origin, right? So that the tail is locked to the origin. We call that a position vector, and that's related to the other vector because my vector has no fixed location. The opposite sides of a parallelogram are 2 different line segments, is one way to think about this, but the opposite sides of a parallelogram are actually described by the same vector. And then the last thing here, 2 lines are the same when they have the same direction and the same location. These lines are said to be coincident. 2 vectors are the same when they have the same direction and the same magnitude. So they don't have to have the same location or position, and these vectors are said to be equal. All right, I'm going to pause the video here before I get started on lesson 8.1.